Okay, so the next problem is the subset sum problem is defined as follows. Given a set of n positive integers, s is equal to this. Okay, so this is a set of n positive integers, and there's another positive integer w. Okay, so is there a subset of s whose elements sum to w? So the question that is asked in this subset problem is that is there a subset of this set? Okay, and this is a set of n positive integers, and if you add those elements in that subset, will you get the positive integer w? Okay, that's the subset sum problem. And to solve this problem, a dynamic program is used, okay, which has a two-dimensional Boolean array x. Okay, so there is a two-dimensional Boolean array x, and this is I have drawn here. So this is now empty. So this is the two-dimensional Boolean array x. It has n rows. So these are the n rows, 0, 1 up till n, and w plus 1 columns. Okay, 0, 1 up till w. So these are w columns. And xij, so xij is an entry in this table or in this two-dimensional array. For this is the range of I. Okay, so I is from 1 to n. Okay, so actually I is from 1 to n, so it's not from 0, it's from 1 to n. Okay, so you have 1 and then you have 2 and so on. It's from 1 to n, and j is from 0 to w. Okay, so yeah, that's fine. Is true if and only if there is a subset a1 a2 up till ai whose elements sum to j. Okay, so this entry xij, okay, so this is I and this is j, so this entry is xij. This will be true if in this subset a1 to ai, okay, in this subset up till ai. That's why we look at this ith position, because our subset is from a1 to ai, and the initial one was from a1 to a, and this is the complete set. And when we talk about xij, we look from a1 a2 a3 up till ai only. That's where we stop. And the sum for the total, we need the sum to be w, but in this case for this smaller one we look up till the sum to j, which is the column. So that's ai ij. So this should be clear in mind that what is xij. So xij is true if there is a subset in this set whose elements sum to j. Okay, so that's the idea. And then we have to answer this question. There are two questions. There are two questions. This is the first one and this is the second one. So we have to answer these two questions. Which of the following is valid for I is from 2 to n? Okay, I is from 2 to n, and ai, so this is ai, sorry, j is in between ai and w. So if you look at these options, so the left hand side is xij. So what I'm writing these things we would be like to be interested in. So I would like to be interested in xij. Okay, and then you look at this thing. Okay, all of them have this thing. So we are interested in another thing, which is xi minus 1 comma j. What else we are interested in? If you look at this thing, this is this thing, we are interested in x I comma j minus ai, and then we are interested in this thing also. So that is x I minus 1 comma j minus ai. So those are the things we are interested in. And then you have this table, okay, and you put true for this condition that we just discussed before. So then what you do is, so what is xij? Xij is out here, okay, so this is some column we are interested in, xij. What else? Xi minus 1j. So what is xi minus 1j? Is this column that we are interested in. What is xij minus ai? Xij minus ai is this column we are interested in. And what is xi minus 1j minus ai? That is this column. So what this one is asking is that you have to fill the entry for xij. You have to tell whether xij is true or not using these. Can you tell that? Okay. So, and then you have this logical expression. See, there is an or sign in between. Okay, because we are using true and false, so you can have this logical or your boolean things out there. Okay. Now, so think about it, that suppose you know about xi minus j, can you say something about xij? Okay, so suppose xi minus j is true. So suppose this thing is true, xi minus j. So what does this tell you? So this tells us that if we take this set a1 comma a2 up till ai minus 1, okay, because xi minus 1 comma j is true, then in this set we can find a subset whose elements will sum to j. Okay, that's what we can do out of this. So if this thing is true, will this thing be true? Okay, yes or no? This will be true. Why? Because if this is true, the subset, the set we look at is from a1 to ai minus 1, and if we change this I minus 1 to I, what will be the set we will be looking at? Then in that case we will look at a bigger set which will have only one element extra. So ai minus 1 comma ai. Okay, so this set that now we are looking at already has this set. So if we can find a sum of the elements of the subset which sum to j, then we can definitely find that sum in this set, because these elements were actually these elements. So this will be true. So what does this tell us? What does this tell us? It tells us that if this is true, then this is definitely true. So then what we can do, we can write something like this: x, okay, I comma j is equal to, if this is true, then this will be definitely true. So what can we say? We can write or in this case, because when we have or, if this thing is true, then it doesn't matter what comes here, it will be always true. So we can have an or. Okay, why we have an or? Is that clear? Because if this is true, then it doesn't matter what comes later, it will be true, and this alone is enough to make it true, because you know this subset something that we just saw. So what this does is it eliminates these options with and. So we can eliminate C and we can eliminate D. Now we are left with only A and B, and the only difference is there. Out here we have I j minus ai, and out here we have I minus 1 comma j minus I. Now let's think about the case when this is not true. Okay, think about the case when this thing is false. Okay, so if this thing is false, then to have this thing true, means the sum of all these elements should sum to j. Then what should we have? Okay, then what should we have? Then these elements. Okay, so what did you do out here? You just added this extra element. Okay, so if suppose these elements, okay, in these elements you can find a subset that sums up to j minus ai. Now think about this thing. Okay, in this subset, okay, this I minus 1 thing, you can find a subset whose elements sum to j minus ai, and then if you include this thing extra, which is actually ai, then you will be able to find the sum up till j, because it was only lacking this thing and you provided this thing. Okay, so in that case, that will make it what we desire, right? We desire to have a sum of j. That's why in this case you will include up till x I minus 1 comma j minus ai. Okay, so which is this one. So this is the correct choice. So is it clear why we included this thing? Because if this is true, then we are done. Okay, if this is not true, then we need this. Okay, then from this subset the sum is not j but j minus ai, and when we go from this smaller entry, okay, to this bigger entry, from x I minus 1 j to I comma j, we include this thing, and including this thing in subset means we can add this thing to j minus ai, because that's the final sum we need, and that's it. So this is option 1. And the second one is quite simple: which entry of the array x, if true, implies that there is a subset whose elements sum to W. So now which entry we should look at, so that for this complete set, okay, this total thing, we can answer this thing that it has a subset whose elements sum to W. So that means the set we should be looking at, what is the set that we should be looking at, is the complete set we should be looking at. Alright, we have to look at the complete set, which means up till an, so last entry, and then we have to check for this sum to be W out here, so which means that this thing should be true out here in that case, so which is option C. Alright.